Everyone, welcome back to Let's Unbound. So we are in second episode of AP Precalculus concept review plus problem solving, and this is all about sine, cosine, and tangent in this trigonometry. So be ready with pen and paper to take down the notes, and yes, sit in an environment where you have no distractions, right? And with this, we are starting our lesson for today. So what is the sine, cosine, and tangent? There are three primary trigonometric ratios used in right angle triangles. We already learned in right angle trigonometry and also in periodic functions, right? And these are just names of the ratio, right? We have many ratios in a triangle. Like if you have side ABC, A by B, A by C, B by A, B by C, like that, many things can be formed. So we just give each of them some name of it. Sine ratio, cosine ratio, tangent ratio. And now these ratios, we are going to learn it as functions. They also act as periodic functions. So that's the aim of the entire unit 3 of this AP Precalculus, right? Now, sine, cosine, tangent, a quick overview for a right angle triangle. Sine theta, if you want to find sine theta, whatever, theta is any angle, you just opposite of the angle theta divided by hypotenuse. Hypotenuse is anyways the same, right? So if this is your theta, then you will use CT for opposite. This is opposite. And of course, hypotenuse is opposite to 90. And adjacent means the theta will be touching. For sure, your angle will be touching hypotenuse and one more side. That one more side is adjacent, which is theta, like your angle will have a contact with that adjacent side. So sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, and tan theta is opposite over adjacent. So in many word problems, we will use this, like, because if your hypotenuse is not needed here, and this is a very simple formula way to remember this. So Cartova. So sine opposite hypotenuse, cos adjacent hypotenuse, tova, tan opposite adjacent. Right? So these are something you already learned this, right? Now, we have to learn some other key terms before, so that these will help you to solve problems based on 3.2. Angles in standard position. Angles in standard position means your initial side should be with positive x-axis. Initial side should be with positive x-axis, and your vertex of the angle should be at the origin. Then your terminal side may be here or wait. Maybe it can be here or here. So terminal side can be anywhere. Even it can come back here. You can say 360, and even more than 360 we can do. Like you do one rotation 360, then you are going 90 or 360 plus 10. So many rotation you can do, a lot of rotation here, right? So this is standard position of an angle. Initial side will be on positive x-axis. Origin, then terminal side will be in any of one of the quadrant. Now, there is two ways I can form an angle. One is clockwise way, other is anti-clockwise way. So this is a normal, like general, they usually will do angle with positive measure. But yeah, sometimes negative measure also will do. So positive means your initial side, and to get your terminal side, you will go anti-clockwise. Okay, so anti-clockwise or counterclockwise, that will give you a positive rotation, positive angle. Negative angle means, yes, still this is my initial, but I'm going to rotate my ray in this way, and this is my negative angle. So measure is same, like if it's 180 plus 20 means it's 200. But depend upon the direction, the sign will differ. Right? So this is angle in standard position. And now, next important thing is radian angle measure. So from here now on, and most of the places in calculus, we will do angles in the form of radians. Okay, radian is also another measurement technique for angles. Like degrees is a measure. Degree, what I will do? In a degree, degree means a circle will be divided into 360 parts. Like 4 parts, 4 equal parts or something like this. Right? I need something like this. 360 parts you should divide, and each part is 1 degree. Okay. Now, that is the one we learned. Now, radian measure is something really useful in our higher studies, especially in calculus. So, what is one radian definition? So, you take a unit circle or any circle with radius r. So we should form one radian angle by radius and the radius and the radius. So I will make a sector so that two radius and then the arc part will also have the radius length. If you can make this, that will make you one radian. Okay. What if I make, okay, this is my radius, for example. I make an angle here. So this is radius, this is radius. This is 2 times of radian. Then it's a 2 radian. Okay. So 3 radian, how can I make? So radius, again, like here I'm making one, like if your radius is 10 centimeter, here you make 10 centimeter. Then again take 10 centimeter. Again take 10 centimeter. And you mark it. So if you cover 3 radius on the circumference, 3 radian will be formed. Radian means if you just mention 3, it means 3 radian. But degree, you should always mention 90 and a degree symbol. Radian, you just mention the number. And most of the time, it will have pi, the forms of pi. For example, one complete rotation is 2 pi. In degree notation, you will say 360. So 360 is equivalent to 2 pi. Right, so pi is equivalent to 180 degree. In radian, it's pi. In degree, it's 180. So the straight line, this will form a pi. And it's not degree symbol, it's pi c. And even if you don't mention it, they will take it as, consider it as a radian only. Right? So now angles on unit circle, coterminal angles. Okay, what is this coterminal angle? Angles in standard question that have a common terminal side. For example, here alpha angle is made. Okay, can you see? Initial on the thing, and this is terminal. So that is some acute angle. Now, same initial, but I am rotating and coming back and forming this angle. So this pink angle is something different. The blue angle is acute angle. Again, the ray is same, but beta is after one rotation I came there. So this is called coterminal angles when two angles whose terminal sides are same, that is coterminal. And to find coterminal angles, you just add or subtract 360 degree. For example, what is coterminal of 60? Add 360. 420 is one example. Then with this add 360. And then you can find many coterminal. All you can subtract. If you subtract means negative come. Negative means we are mentioning this clockwise direction. Right? And next part. Radian angle measures. So this is reference angles in which is one more important. An acute angle formed by the terminal side of an angle and x-axis. Acute angle. But is it only acute angle possible to us? No. Let's see how it works. So this is my initial axis. Like obviously I should start from here. And if your terminal side lies on first quadrant, then your reference angle theta r and the actual angle is same. Okay, the green is actual angle, theta r is reference angle. Now I want to put my terminal side on the what we say, terminal side on the second quadrant. Now obtuse angle is formed, but reference angle means it's always acute. So this is theta and your terminal side and your one of the x-axis. This time it's not always positive x-axis. So the other x-axis, that will be theta reference. Okay. Now if it is on the third quadrant, initial ray and your angle goes like this and this. This time the reference angle theta with your terminal ray and the closest x-axis. Okay, don't go here. It will be again an obtuse angle. Now the last one is fourth one. Theta r, like fourth quadrant is here and I am forming an angle like this, reflex angle. But your reference angle would be the terminal and the x-axis, the closest x-axis that you can see. Okay, this is reference angle concept. And let's move to next. Sine, cosine, and tangent on the unit circle. What is unit circle? Unit circle means center is at the origin and radius will be 1, either 1 centimeter, kilometer, whatever. Okay. Radius is 1 unit. And this is not unit circle. Now, how can we define the sine, cosine, tangent on a unit circle? Super simple. Let me take an angle in first quadrant. First quadrant is simpler because both of them are positive. And let me mark this point as PA, comma B. Okay. Now, what does it mean? So when you come from here to here, its vertical distance is B. This is B, and horizontal distance is A. Correct? So this is P of A, comma B means then horizontal. This is what a right triangle will be formed. Now I will have an angle here. Let me mark theta. And radius is 1. Or the center to this is 1. So now I have a right triangle, hypotenuse 1. One of the other sides are like A and B. Now let me find sine theta ratio as a ratio. Sine theta is opposite by hypotenuse. B by 1. Sine theta is B. Then cos theta is adjacent by hypotenuse, A by 1. So cos theta is A. So in a coordinate plane, you can take a point and represent as A, comma B. But on this unit circle, any point can be written as P of, instead A, you can put cos theta and then sine theta. It's not X coordinate, Y coordinate. Based on the angle, we can define that coordinates. Right? And next. So I take A and B. Here they took X and Y. Very simple. Now, what if, is it only possible on unit circle? No, other radius also you can take. But for other radius, instead unit circle, X is equal to R cos theta, Y equal to R sin theta. Okay. If it's a unit circle, R becomes 1 and I just got X is cos theta and Y is sin theta. Got it? Now coming to tangent. Sine and cos are like very important basic, and tangent is just by dividing them we can find. Tangent of an angle is ratio of sine to the cosine of that angle. So it's sine over cosine. Yeah. So, and yes, we are solving some questions now. Question number 1. The figure below is a circle in xy plane with center at the origin, an angle theta in standard position. The point A, comma B lies on terminal side of the angle and on the circle. Find cos theta, sin theta, and tan theta. Okay, how to find this theta? You have to use reference angle. Okay, this is theta, but in my solving, I will use reference angle. So let me take out this right triangle. A right triangle, if you make, you will drop down, and then you will run to the origin. So it's 1 by 2, because vertical means y coordinate to B. Horizontal, you run this -10. So yes, -10 we will take, because it's just about the sine cos ratios, it can be -2, right? So don't ignore negative thinking that right angle triangles cannot have negatives, right? So now, take the right triangle and reference angle, let me put it theta. Okay. Then this is 90, this is half, this is -10, and we need to calculate the hypotenuse. So it's square root of your other two sides should be square. -10 square is 100, 1 by 2 square is 1 by 4. Now I'm multiplying by 4, so it's 401 over 4. So you apply the roots for numerator and denominator. So eventually you will get √401 by 2. So this is my hypotenuse. Now, with this we can find cos, sin, tan. That's simple. Right? So this is a right triangle. We have -10 here, half here, √401 divided by 2. Now what is sin theta? Opposite over address. This is my theta. Okay. Opposite over hypotenuse. 1 by 2 divided by. I am using this division because lot fraction involved. Divide, again divide. So that's why. √401 divided by 2. So 1 by 2, divide change to multiply. 2 divided by square root 401. 2 to cancel. 1 by square root 401. Yes, if you want to rationalize this, yes, you can do multiply by 401 and divide by 401. It's 401 divided by 4 sine theta. And coming to cos theta, it's adjacent over hypotenuse. Adjacent of theta is minus 10 and it's square root of 401 by 2. The 2 will multiply here. So basic fraction thing. And we got this. Finally, tan theta is opposite over adjacent. Opposite is 1 by 2. Adjacent is minus 10. So it's minus 1 by 20. Right. So that's all for question number 1. Second question is, in the coordinate plane, an angle is in standard position with its terminal side passing through the point minus 12 by 13, comma 5 by 13 on a unit circle. Which of the following is true? So we already did in a unit circle. A point, like if it's x comma y or a comma b, it will be represented by cos theta comma sine theta, right? So this point implies cos theta is negative 12 by 13 and sine theta is 5 by 13. So sine theta is minus 12 by 13, it's wrong. Sine theta is 5 by 13 is right, others are wrong. So it's option C, right? And we are moving to third question. Here we see an angle theta is in standard position in the xy plane. Which of the following is true about theta on the interval 0 to 2 pi if sine theta is less than 0? So where sine theta is less than 0? And first let's understand the question. So we are focusing on one complete rotation, 0 to 2 pi means. And sine theta to be negative means. Let me do like this. Sine theta negative means y coordinate is sine theta. Correct? Y coordinate will represent sine theta. So where y is negative, y is positive here. This is y positive. This is y negative. So that is two quadrants will have y negative. What are the quadrants? Third and fourth. So if sine theta is negative, then for sure that theta should be in third quadrant or fourth quadrant. Okay, so first statement. There is no value of theta on 0 to 2 pi for which sine theta is less than 0. No, there are some values where third and fourth quadrant, whichever values comes up, they will have sine theta less than 0. So this statement is not correct. There are values of theta for which the sine theta less than 0 in all four quadrants. No, sine theta is positive in first quadrant and second quadrant. They are telling it's negative in all quadrants. So this is also not correct. C part. There are values of theta on which sine theta is less than in quadrants 3 and 4 only. Yeah, I already did. And we are sure it's 3 and 4 only. So this is correct. But let's check the option also. There is a value of theta on which sine theta less than 0 in quadrant 2 only. Quadrant 2 is absolute positive. So it's not. So it's option C. Okay. Right. And that's the wrap for today's lesson. Before that, yes, I have a bonus question to you. So take a screenshot, do try solving this. Also, if you want to reiterate the concept, you can just rewatch the video, save the playlist and share it with your friends. And yes, here we have, yes, if you want to join Let's Send One Students Community WhatsApp group, you can scan the QR code given here. Okay, that's good. That's it. Keep learning, keep practicing.